Hello. Hello, I'm Seungmoon Song. I'm a postdoc with Steve Collins, and this is another talk on human-in-the-loop optimization, but it'll be on increasing walking speed. So, as many of you here, our goal is to improve locomotion performance with assisted devices. In this case, with ankle exoskeletons. There are different performance measurements in locomotion, and the goal of this project is to increase walking speed, which can be especially helpful to people with gait pathology, such as chronic stroke. To achieve this goal, we use human-in-the-loop optimization, which our lab has been successful with in reducing metabolic energy consumption during walking and running. And to briefly recap, while a participant walks with an exoskeleton controller, the algorithm estimates the performance you want to change, then feed that information to a numeric optimizer, which produces new controllers to evaluate next. So in this project, we use CMAES as the numeric optimizer to find 4 control parameters for our ankle exoskeleton controllers. And most importantly, we aim to increase preferred walking speed. It is a generic optimizer. It stands for covariance matrix adaptation evolution strategy. It's useful if you don't understand about the cost. So how do we measure preferred walking speeds? We simply measure participants' self-selected walking speeds on a self-paced treadmill. Specifically throughout the experiment, we let participants to walk on a self-paced treadmill and instruct them to walk at a comfortable speed. Then we measure their walking speeds while applying various exoskeleton controllers. For this, we developed a self-paced controller for an instrumented treadmill. The software only uses force plate data to estimate walking speed, then controls the treadmill to match that speed. We compared various overground and treadmill walking conditions with 10 subjects. I'll be happy to share the details later, but here I only want to say that our self-paced treadmill reliably captures overground walking speed, at least for normal shoes. The plot compares the overground preferred walking speeds using standard measurements on the x-axis to those on our self-paced treadmill on the y-axis. So now we are ready to conduct human-in-the-loop optimization to change preferred walking speed. In the first day, participants go through familiarization sessions, trials for walking on the self-paced treadmill and the ankle exoskeletons. And starting from the second day, we conducted human-in-the-loop optimization and validation trials. And I'm very excited to share the results, but I want to make it clear that this is from only one subject, and although we piloted 1 more subjects who showed similar results. The numbers are from the validation session in the second day of human-in-the-loop optimization. The first here shows that the self-paced walking speed does not change much when walking with the exoskeleton when no torque is applied. And to compare, we also tested a controller from another experiment that was found to minimize metabolic energy while walking on 1.25 meters per second. And it is interesting to see that the subject chose to walk faster, even though the controller was tuned for a slower speed. And now this is the walking speed with the controller optimized for faster walking. And 1.9 meters per second is about where healthy adults start to run instead of walking. So it is quite a fast walking, and it appears that we are able to increase walking speed. And during the validation session, we also collected the respiratory data to estimate metabolic energy consumption, and we calculated the cost of transport, which is the metabolic energy consumed per walking distance. And excitingly again, the cost of transport was about 16% lower when walking with the controller optimized for faster speed. Again, this is with only 1 subject, but it seems like we know how to increase preferred walking speed with ankle exoskeletons. And we are really excited about the potential extension of this study. For example, to minimize cost of transport instead of energy for a given speed, and to increase walking speed in people with chronic stroke or amputation, who would benefit a lot. Thank you.